lecture we are going to test the performance of logistic regression model. We will use Python and I will show you in a demo how to check the performance of a logistic regression model. The agenda for this lecture is Python demo for accuracy prediction in logistic regression model using ROC curve. There are two terms very important, one is sensitivity, another one is specificity. For checking what type of error we are making, we use two parameters. One is sensitivity, the another name for sensitivity is true positive rate. This also I have shown you in our previous lecture, that is a TP divided by true positive plus false negative. Specificity is a true negative rate, it is a true negative divided by true negative plus false positive. In this lecture I am going to say the connection between sensitivity and specificity for different threshold value. The first case is when the threshold value is low, when the threshold value will be there, suppose this way. Suppose when you put threshold value here, that will increase the sensitivity, but it will decrease our specificity. When the threshold value is higher, suppose if you keep your threshold value here, what will happen? Specificity will increase, sensitivity will decrease. So, which threshold value should be chosen, that is the problem, that I will show you with the help of Python programming. First we will check what is accuracy. Accuracy is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. So, the accuracy for our problem is 0.76. Then specificity is true negative divided by true negative plus false positive. For our problem it was 0.94. Then sensitivity is true positive divided by plus false negative. For our problem sensitivity is 0.44. We got this specificity and sensitivity by taking threshold is 0.5, that is our default value. But the question will come, if it goes above 0.5 or below 0.5, what will happen and what should be the correct value. Now we will draw the ROC curve for training data set. So from sklearn.metrics import ROC underscore AUC underscore ROC underscore AUC underscore sklearn.metrics import ROC underscore curve comma AUC. Then log of ROC underscore AUC1 equal to ROC underscore AUC underscore score y train comma y underscore predict train. Then FPR TPR, that we will find out false positive rate and true positive rate, and threshold also we are going to test it. So, when you plot it, FPR and TPR, threshold 1 equal to ROC underscore curve y underscore train comma y underscore probability underscore train. So, ROC underscore AUC1 equal to, so we are going to draw AUC curve under FPR1, that is false positive rate and true positive rate. When you plot that, we are getting for different combination of FPR and TPR, we are getting for default ROC curve. So, the area under AUC for this model is 0.64. Now, let us draw the ROC curve for the test data set. When we see that only these things are changed, when we draw ROC curve for test data set, what happened when compared to this, here the AUC area under curve is increased because 0.9. So, what we are infer from the previous one, this one is, so this model is performing well for the our Y test data set because this AUC is 0.9. How to select threshold value? The outcome of logistic regression model is a probability, you know that. Selecting a good threshold value is often challenging. The threshold value on ROC curve you can take if it is 1. If the threshold is 1, what will happen? The true positive rate is 0 and false positive rate also 0, this situation. So, this is the place where t equal to 1. When threshold is 0, so true positive rate is 1 this point and false positive rate also 1. So, threshold values are often selected based on which error is better. At present randomly we choose some threshold value 0.35. Let us compare with by changing different threshold value and verify which threshold value is right choice for us. For that y underscore predict underscore class 1 equal to binarize y underscore probability dot reshape 1 comma minus 1 by taking 0.35. So, if you take 0.35, this was our predicted values, but if you want to get into the integer value you have to use y underscore predict underscore class 1 dot as type integer, you are getting this integer value. Then from that we can get the confusion matrix. So, what it says that by keeping threshold value is 0.35, so true positive is 9 and true negative is 8. So, we can change different value, for example for that value also we can check our recall and precision. Now, by taking threshold value as a 0.5, let us verify what has happened, that confusion matrix value it is increased. So, the true negative is 15, true positive is 4. So, what has happened, there is a, you see that the recall previously it was 0.5, now it is 0.94, that was the value of 0.50 of the threshold value. If you take threshold value 0.7, what is happening here, the true negative value is increased, but there is no true positive at all. So, what is happening, after certain threshold value we are not able to get true positive values, but the other values are little improved. But the question will come, how to choose the right threshold value. We have seen 0.3, 0.5 or 0.7 and the appropriate the t value that can be get by looking at this table. For example, here the output of this program says that the threshold value should be 0.457 is most appropriate for us. Now, optimal threshold value in ROC curve, what has happened here, in x axis we have taken 1 minus false positive rate, in y axis we have taken true positive rate. So, in the intersection point where the true positive rate and true negative rates are intersecting, so that point considered as the optimal value of threshold value. So, here classification report using optimal threshold value, this was our program output. So, here I use the binarize y underscore probability dot reshape. So, this is our predicted value. So, we got confusion matrix, here true negative is 14, true positive is 8. For that we got the classification report also. Here it says that you see that specificity and sensitivity both are little higher. Okay. So, it shows that this is the optimal threshold value. Now, with the help of Python I am going to run the code, I am going to explain how to choose the correct threshold value. So, import necessary library, I have imported pandas and imported matplotlib.pyplot. Then this was the data set. This data set already I have discussed with you. There are 2 independent variable and 1 dependent variable, that is coupon. So, we will describe this data set. It will give you a basic statistics about all the columns. For spending there are 100 data set, the mean is 3.3, standard deviation is 1.74, minimum is 1. So, 25th percentile, 50th percentile, 75th percentile, maximum is 7.07. For card we can look at only the count value because there is no meaning for mean and standard deviation. Similarly, for coupon because both the variables are binary variables. Now, we will look at what is the value in the column coupon. There are 2 values there, one is 0 and 1. 0 means that coupon that customer did not use the coupon, 1 means that customer has used the coupon. Now, let us see how many zeros and how many ones by using value underscore counts function. So, there are 60 people did not use the coupon, 40 people have used the coupon. So, the baseline method 0.6. Now, we will go for building the logistic regression model. I have imported linear underscore model, sklearn dot model underscore selection. I have imported train underscore test underscore split. There also I have imported logistic regression. Then we will split the data set by in the ratio of 25% data sets for the training, remaining 25 data sets for testing. So, let us see how much training data set, how much test data set. So, for x variable the training data is 75, for y variable the training data is 75, for test data set for x is 25, the test data set for y is 25. Now, we will construct a logistic regression. So, we use the solver LBFGS. Then we will predict our constructed model with the help of test data set. In our model, after substituting x values, this was our predicted y value. We can get to know there are different solvers. When you use the logistic regression question mark, you can get to know there are different cases. For example, this is the help function. You see that currently the multinomial option is supported by only by the LBFGS. There are some more method, SEAG method and Newton CG method that we are not using. So, that is why we have used LBFGS solver for getting this logistic regression output. Now, we will predict our model with the help of test data set. This was our predicted y value. Here the input is the test data set. Now, we will take the training data set, then we will predict the model, because the training data set there are 75 data set, here only 25 was there. So, this was our predicted output for the training data set. Now, we will get the probability value for this. So, this is the probability for our training data set. So, there will be 75 data set is there is a different probability. Our question comes, what should be the threshold value or cutoff value, so that we can classify this is 1 or 0. Now, for the test data set also there will be 25 data set, we can get the probability. Now, we will run our regression model. This is our predicted model, but here we have to show that what should be the threshold value. First, we will check the accuracy of the model. For knowing the accuracy of the model, you have to import accuracy underscore score. So, the accuracy is 0.76. Next, we can go for constructing a confusion matrix. For that, you have to import a new library called confusion underscore matrix. When you run this, you are getting this confusion matrix. Here the confusion matrix is, see, default value is 0.5 is taken. So, this 15 says the true negative, the 4 says true positive, the 1 is false positive, the 5 is false negative. So, in our data set, say that the same thing, true negative is 15, false positive is 1, false negative is 5, true positive is 4. Now, we will get to know what is the classification report. That classification report, important things you have to remember, one is the recall, another one is the support. The recalls gives us an idea about what is actually yes and how often does it predict yes. The recall value for 1 is called sensitivity, the recall value for 0 called specificity. The precision tells us about when it predicts yes, how often is it correct. So, precision is true positive divided by true positive plus false positive for 1. The accuracy is the diagonal values of a confusion matrix is the accurate values, that are TP and true negative, divided by if you add all the cells value, that is our accuracy. Now, the recall is TP divided by TP plus Fn for value of 1. The F measure is giving the balance between precision and our recall. Now, we will go for finding accuracy. The accuracy is 0.76. Then we will go for specificity. The specificity is 0.94. Here the default t value is 0.5. So, we will go for sensitivity, that is a true positive rate. When you for true positive rate, it is a 0.44. Now, we will go for ROC curve. Now, we will plot that ROC curve. For default value, the ROC curve is that blue one, which says the area under curve is 0.64. Now, we will see different false positive rate and true positive rate. So, this was that one. Now, let us see what are the values of our false positive rate. First, I will say FPR. These are the different false positive rates. Now, I will display the output of true positive rate TPR. This is true positive rates. So, these values are going to be our x and y axis of our ROC curve. For different combinations, we may get different ROC values. So, we will plot ROC curve. This is for our test data set, because you see that here the value which I have taken, this is y test data set, this was our ROC curve. When you look at these two curves, you see that here this is for, when you look at this data set, this is for our training data set. For training data set, ROC curve is this like this, see the area is 0.64. For the test data set, the value of ROC curve is 0.9. So, our model works very well for the test data set. Now, let us randomly give different t value, different threshold value. Let us see how the ROC curve appears. Suppose I have taken ROC curve, see this is 0.35 is the threshold value. Let us see what is ROC curve for this value. So, I have predicted values, then that value I need an integer form, I have taken an integer form, then I am going to draw the confusion matrix. See here the confusion matrix is true negative is 8 and true positive is 9, because here the value is 0.35. So, there will be, if it is 0.35, see there are higher true positive rate, that is 9. For this value, let us draw the true negative 8, see true positive is 9, because our threshold value is low, everything will be predicted as positive. Now, let us get the classification report for that. So, this is our classification report. The recall when it is 0 it is a 0.5, recall when it is 1 it is 1. Now, let us go for another threshold value, that is a 0.5. When it is a 0.5, you see that I have changed this value into 0.5. Let us predicted y value, this is a predicted y value. Then let us draw the confusion matrix. What has happened? The threshold value has moved on right hand side, we are getting more true negative and less true positive values. For this, let us get the classification report. You see that this 0 represent specificity is increasing. So, what is happening here? And sensitivity is decreasing. When you move towards right hand side, when the threshold value goes towards right hand side, what is happening? Specificity is increasing, sensitivity is decreasing. The previous curve, you see that when it is low this side, you see that the sensitivity is 1 almost, it is 1 exactly. When we are having low value of, low value means our 0.35. When it is a 0.35, you see the specificity is 0.5, but sensitivity is 1. So, when the threshold value is increasing, what has happened? That the specificity increased, but the sensitivity decreased. Let us go for 0.7. When the threshold value is 0.7, this is our predicted value. Let us go for confusion matrix. So, when the threshold value is high, you see that there are more true negative, because it is extreme in the right hand side. So, what they say, whatever like it kind of a pathology lab that whoever goes there they will get a negative report. So, that is the effect of changing the threshold value from lower side to upper side. Now, let us get the classification report for this. See that here the specificity is 1 when you are having higher threshold value. So, sensitivity is 0 because you have chosen higher threshold value. Now, the important task is in our class we have to choose what is the optimal cutoff point, or cutoff point in the sense optimal threshold value. So, we will import this ROC curve, then we will run this ROC curve underscore y underscore test and y probability, then we will print area under ROC curve, that is the AUC curve. The area under ROC curve for optimal threshold value is 0.90. So, it is the best one because it is nearer to 1, but we want to know what is the optimal threshold value. For that purpose you have to run this one, that is import numpy as np I equal to np dot range for because TPR. For each TPR value we have to get ROC equal to PD dot data frame, PD dot series false positive rate, then we are getting different index values. So, when you run this command you are getting a table which shows the optimal threshold value. So, what is the meaning of this one is if you take the t value is 0.457 that will give you the higher area under curve. So, when you run this you see that the blue line says that true positive rate, the red one shows the 1 minus false positive rate. So, this intersection and corresponds, see that this intersection where the here what happening, the true positive rate also high, here the 1 minus false positive also high. So, this is our optimal value. Suppose for that optimal value let us draw our new ROC curve. This was because you see that here I have taken 0.45. So, I have drawn the confusion matrix. You see that here the confusion matrix 14, that is a true negative is very high, but here 8 true positive also very high. So, when you take threshold value is 0.45 you are getting higher true negative value and higher true positive value. When you look at classification report you see that the specificity value is 0.88, the sensitivity value is 0.89. In this lecture I have taken a sample problem. With the help of sample problem I have explained to you how to construct a confusion matrix and how to choose the correct t value, correct threshold value. We have chosen different threshold value. For example, we have taken threshold value 0.35, then we plotted the ROC curve, then we have taken threshold value 0.5, then we plotted the ROC curve. Next we have taken threshold value above 0.5, that is a 0.7, then we have plotted different threshold value. Then if we compared when we improve or when we increase our threshold value, how that ROC curves differs. At the end we have chosen the optimal threshold value. In this problem we got it as a 0.45. Then for that optimal threshold value we found the AUC, that is area under curve, that also very high. So, this is the way to choose the correct threshold value for checking the quality of our classification matrix or regression models. Thank you very much.